So next one we're going to look at is a self-destructing message. Bum 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 bum. Doon 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 doon. This message will self-destruct in 30 seconds. Actually, we're going to have it self-destruct in 10 seconds. So we don't have to wait 30 seconds. And Kai, you're going to really like this. Well, because we're going to get into crypto and creating an app, which allows completely secure sending somebody a message completely encrypted, and they could receive it and unencrypt it. So localhost 80, I could put in some message. And I submit it. And here's a key to my secret message, right? And if I click that, it takes me to this URL where it gives me, looks it up by that, right? And that's cool, shows me that. But if I wait 10 seconds, ooh, it's gone. And it only blows up after I've read it. So you read it, you got 10 seconds, then it's gone. So how do we do that? The first thing is we come to the route, and we have handle index. And we have a request method equals post. And if it's post, we're going to do this chunk of code from there to here. Okay. And if it's anything other than post, we're going to do this. So post means they've submitted, they're posting, they've submitted a form, they're posting, so we're going to handle that. And otherwise, right, we're just going to show them the form, and they could enter some information and then submit that. And so the else goes from here to there, and all that is HTML. Write a response with this HTML. And the form's text area is message. So when we come up here and it's posted, we're saying, give me the value that was sent from that form that was in the message field, right? Because whatever is in the form, the value in that field gets stored in a variable name of message or whatever you've given the name, right? So that becomes the variable that you then access it. So we're accessing what came from that form, request form value, and we assign that to a variable message. And then we get a random key. So UUID, universally unique identification, we create a key. And that's just a function that is running at, this package, go UUID. So it's kind of weird. The package is called, go UUID, but in code you reference the package as UUID. And there's no alias that was added to the front saying, hey, this is UUID, right? There's no alias there like that. It's called go UUID, but you reference it as UUID. Kind of strange. It's the only package I know where it's like that. And then I'm sure there's a reason that I'm not aware of. And then we create an object, and we create a Memcache item. What is a Memcache item? We go to godoc.org, and we go to Golang. We go to Golang App Engine, and then under Services, we have Memcache, and in Memcache we have our reference. So here's our reference, and I'm just, if we go to godoc.org and we search for App Engine, then we go into App Engine, and look at the bottom, we have Memcache right here, and it's the same deal. You could see, that and this, right? We got package Memcache provides. Package Memcache provides a client for App Engine's distributed in-memory key value. Item 0 else fprint memcache miss. Item 0 else fprint memcache miss. Right? So same documentation, just showing you it in two locations. For whatever reason, by habit, I like to go look at it on App Engine's page. Just look at the reference there. And so when we have that, when right here we're creating a variable item, and it's of type item from the Memcache package. And there's the Memcache package, App Engine Memcache. And the item has a key value. So what is an item here? We can look through here, and here's an item. And so an item is a struct, and it has a key value, is the item's key, 250 bytes maximum, and the value is the item's value. It's a slice of bytes, slice of byte. Okay. How many people just show hands like this is going too slow for you? How many people show hands it helps to see like, oh, okay, this is where I look that up and see how the things work in the doc? Show hands. Yeah, that's totally helpful to me too. So I do a memcache item, right? I create a variable item, and it is of type memcache item, which is a struct, and I set my key and my value. And so the key is this UUID, which when I do a UUID, and I can look this up at that on godoc.org at this location, right? godoc.org / all of that, or I could just write here in WebStorm. I could click new v4 UUID, and it takes me to the source code. And you can see here that it takes nothing, and it returns a UUID and an error, a pointer to a UUID and an error. Well, what's a pointer to a UUID? Pointer to a UUID is an array of size 16, array of byte, size 16, right? Okay, so it's an array of bytes, size 16, and but really what that is a pointer to a UUID. That's what key is there. So when we do new v4, we get a pointer to a UUID and an error. So I have my UUID right there, pointer to a UUID. And when I have a pointer to a UUID, so let's go look at this in the docs now. godoc.org, and I could just type in UUID. And here's the new 7 hatch, go UUID. And when I have a UUID, type UUID, a pointer to UUID has these methods right there. And one of the methods is string. And it returns an unparsed version of the generated UUID sequence, gives me a string. Okay, so that's a method I could call off of a pointer to a UUID. So I have a pointer to a UUID, and I call string. So it takes that universally unique ID, turns it into a string. So I put that here as my key, and then my value. My value we saw when we were looking at that. My value is a slice of byte. And so here I take my value, which is some message that was sent in, and I turn it into a slice of byte. Why can I take a string? How is it that I could take a string and convert it to a slice of byte? Conversion. So yeah, and in some languages it's called casting, and sometimes in Go I see it referred to as casting. But if you look at, and so typecasting is absolutely right, Kai. And the only reason I hesitate is if you look at golang.org, and let's look at Golang language spec, Golang spec. And if we look for cast, nothing, right? Nothing showed up. If I go to effective Go, and I look for cast, nothing showed up. But if I look for conversion here, right? We talk about conversions, and you can see all the stuff that's convers, right? Something about conversion. And here we conversion, right? So the word cast isn't used. Yeah, and I'm not totally sure why, but we're converting from one value to another. So here is how is it that we could take a string and convert it to a slice of byte? Yeah, but why? What is a string?
It's a bunch of characters.
Okay, so a string is a bunch of characters. And what's a character? It's a UTF-8 code point. What's a UTF-8 code point? It's 1 to 4 bytes, right? So 1 to 4 bytes. And ASCII is 1 byte. Get into Chinese characters, 3, maybe 4 bytes, right? And so a string is a bunch of characters, and each character is a UTF-8 code point. Each UTF-8 code point is 1 to 4 bytes. So a string is just a collection of bytes. So it's also a slice of byte. So we could turn that string into a slice of byte. And then we do our memcache add. We give it our contacts, and we give it an item. and we check to see if there's an error. So we just added that string with this key to Memcache. And so when we do that, right, so if we go to handle index, let me just make sure this is still running. I don't know which one I'm in. I'm in O1, print working directory, self-destructing message, go app serve. Is that everybody? Who did I leave out? Rio, Bob, Carson, Daniel, Kai, Ruben, Patrick. Anybody? Todd. Did I get everybody? So I submit that. It gives me this unique ID. So I could now go and look on my developer's console at localhost 8000. And I can look in Memcache. I can't just see all the Memcache stuff, but I could paste in that key, and I can display the value associated with that key. Right, so that's what that code did right there. Was it created a Memcache item, and then it added that item using our context to Memcache. And then we write that, right? And then we write a response. And what we write out basically is here's your self-destructing secret message ID, right? And so we give it the key string. So that key, again, right? We took it here and we just turned it into a string, and then we show that. So we give it an anchor, go to this path, go to my web app /message / and then that unique ID. And then when I'm going to, what's the other one? I'm going to get that out, right? So if I was to click this, if I go to /message, which I just did, I just went to /message, and then here, I'm basically pulling that item out of Memcache and showing it. How does that work? So I went to /message right here. So I'm now going to run this. When I run that, handle message, this is the code that runs. And so with handle message, right, we get app engine context, and then we're going to split the request URL path. So we're going to split all of this right here. We're going to split that up. And how are we going to split it? We're going to split it up by its slashes, right? And so we've got slashes there. So we're going to split this string up by those slashes. And we're going to, I want 3 things back. So it will give me first, so it looks at everything, like when it splits on this first string, it'll give me what's right here, which is an empty string. So it's not even going to be a space, even though I just added a space for illustration. It'll give me an empty string, and it'll give me that. So that's 1, 2 items. And when it splits on this one, it'll give me this. And that's my 3 items. So when I say split in and give me 3 things, that's what it does. It splits on 2 slashes. So even if I had more slashes here, right, the third thing would be all of that, even though there's more slashes in there. And if you look at split, right, if you look at split in the strings package, there's a couple of splits we could use. We could use split, split after in, split in. So split would split it all up by slashes, and here's all your stuff that was divided by slashes, delimited by slashes, like comma delimited, but we're using slashes. So that'd be split. Split in is saying, just give me a couple of things. And, right, so you give the separator the slash, and then how many things do you want? I want 3 things. And it gives you a slice of strings, so all that stuff split, and it puts it into a slice for you, which you can then access by index. So I'm saying, hey, give me the thing at index position 2, which is the 3rd item, because first item's at index position what? 0. Second item's at index position what? 1. And third item's at index position 2. So if I get the third item, the thing at index position 2, I'm getting that right there. So now that I have that key, I could do memcache get context key get my item. It gave me memcache item, right? And then here basically I'm saying write out the item value. Show me the item value. Show it to me. What's the value there? How do I know I could use value? If I go back here to the documentation, and somebody tell me how do I get to the documentation for Memcache at this website, godoc.org. How do I get there? App Engine? Now what? App Engine?
Yeah.
And now what?
Control F.
Okay, Control F. Command F on Mac, Memcache. Right, cool. And so that's down here at the bottom. They list the other directories inside of App Engine. And so here's Memcache. Internal Memcache, Memcache. I'm going to go with this one. And then here in Memcache, I was wondering how could I use value? So I could look at my item, right? And I have item and func get context gives me a pointer to an item. Well, I'm looking for a pointer to items that allow me to do something called value. So Control F value, right? And here's some examples where that's being done. And there are things that take values, but I don't see any methods value, right? So it makes me wonder, what is an item? All right, so let's go look at what an item is. Oh, an item right here has a value, right? It's just part of it. So value is the item's value. Object is so that's the value. But where is it that I'm allowed to, that's it. It's not a method. It's just give me that value. Sorry. It's a field. It's a struct with a field. I was calling it a method. Sorry. Good confusion. Do you understand where I just clarified though? Right? It's just a field. So we could just say, give me that field. Huh?
So like whatever the item is, it'll just give you the value and it's just built into.
Well, here is when we ask for, when we say get, so here is get. When we say get, it gives us, let me get rid of value up here. When we say get, it takes a context and a key, and it returns a pointer to an item and an error.
An item is a struct.
Hmm?
So an item is a struct. So it can have several fields. So when you ask
Yeah, and so when it returns,
all the fields. Or
yeah. So if we wanted to, right, we could also see what else is there. Expiration flags, key, object value, and those are all from expiration, key, fields, object value. They're all from here, the fields of the struct. So that's when we get. You know what's interesting though, just out of, I was looking at get multi, no wonder. So where's get? Just get gives us a pointer to an item. Get right here, pointer to an item. So get gives us a pointer to an item. So what's this code right here do? It takes the flags field, and if we look at the flags field on an item, the flags are a server opaque flag whose semantics are entirely up to the App Engine app. What does that mean? Like when I read that a couple of months ago, I was like, I have no idea what that means. What's that mean? What's server opaque mean? What does opaque mean?
can't see through it.
Opaque, yeah, opaque is you can't see through it, or you can't see into it, right? So if we just look up opaque, not able to be seen through, not transparent, an opaque thing or substance. like opaque glass is frosted glass. And so this is opaque. And to whom is it opaque? The server. So the server App Engine can't see into this variable. App Engine doesn't care about this variable. Whose semantics? What does semantics mean? That's like redundant almost. What does semantics mean?
The meaning.
Semantics is meaning, right? Relating to meaning in language or logic. Okay, so now we're starting to get somewhere. Flags are server opaque flags. Server doesn't care about this stuff. Whose semantics, whose meaning is entirely up to the App Engine app. What is the App Engine app? That's what we're doing. That's my stuff, baby. So App Engine does not care about flags. The meaning of the flags, if I set them, is totally up to me, the guy who's building App Engine app. So I could use flags however I want. And you could get pretty complicated with flags. There's like, flag, bit shift. Did I type shit? Why use bitwise shift operator for but you could do things where your flag is has different values. Right, and each bit location means something. You could check for that, and you could do bit shitting. And when you do bit shifting, right, then whatever. So here we say, hey, is the flag 0? And we're checking to see if it's 0 because it is a uint32. What is the 0 value of a uint32? So Golang spec types, numeric types. Here are my numeric types. What's the 0 value of a uint32? What's the 0 value of an int? 0. What's the 0 value of a float? 0.0 or 0. What's the 0 value of a string? Empty string, right? Nothing in it, just 2 double quotes. What's the 0 value of a map? Nil. What's the 0 value of a channel? Nil. What's the 0 value of a slice? Nil. Because those are all reference types pointing to some data structure that's not been created yet, so they're nil. Slices, maps, and channels are all reference types. And 0 value on those is nil. And then 0 value on an int is 0. 0 value on a float is 0. 0 value on a string is empty string. 0 value on a bool. False. So if we do 0 and the 0 value and false for booleans, 0 for integers, 0, 0 for floats, empty for strings, and nil for pointers, functions, interfaces, slices, channels, and maps. All right, so we know that the 0 value of an int is 0. So the first time through here, all right, we're just going to say, hey, is that 0? Yeah, that's 0. All right, well, let's set the item expiration. Going back to this item deal. There's an expiration, which is a time duration. Package time, a duration. Duration is like, what's the difference between duration and expiration? What's an expiration time? At this time, you're going to expire at 4:32, 4:39 expire, right? So that's an expiration time. An expiration duration is like, you know what? In 30 seconds expire. I don't even have to worry about the time. That's a duration. So we're just giving it a duration. So there's a field expiration. It wants a duration, right? And so we're just saying, hey, item expiration in 10 seconds. Time from package time, 1 second multiplied by 10 seconds. And then we're, huh?
Could you do time.minute or something like that? And then it would convert it? Or would you not?
You know, they've got like all of them. And you can just go look at the package and see like, you know, like if we go and we look at the time package. So where's the time package? Time. It's part of the standard library. So go doc. So, you know, look down through here. So here's some constants. So different formatting styles for time. There's some sleep, and it sleeps for a certain duration. And what's sleep do? Sleep pauses the current go routine for at least this duration. There's an example. Duration is just N64. And here are some nano, micro, millisecond, minute, hour. So nano, and microseconds, 1,000 nanoseconds. A millisecond is a million nanoseconds. A second is a billion nanoseconds. A minute is 60 billion nanoseconds. There's 60 billion nanoseconds in a minute. 3.6 trillion nanoseconds in an hour. I think that's right. So there are constants, right? And so here we did, how did we use it? Time.second. So we could just access that right from it's a constant in the package. And here's it shows you how to get a second. Second is equal to time.second. And then we can take a second, divide by millisecond, right? Millisecond. And one second is 1,000 milliseconds. So that prints 1,000. And this had to be cast in N64 because, not sure. So one of those is that'd be interesting to run. Any little thing right there lets me run it? No. That's how you learn, right? So I might take this and go to golang.org, and I could just put it right here. And I'm also going to have to import. So let me put this to what's pop-out do? Now I'm at the Go playground. That's better, easier, and I need time. And I could format that and run it. So there's 1,000, and I could take I could say what is the type? Format dot print f %t second. Unexpected, comma. So it's time duration. All right, so second is time duration, and I could take that. Whoops. And I could do int 64 because the underlying type of time duration is duration is an int 64. So now it's N64, time duration N64. I used conversion right there. And then here, what is time.millisecond? Time.milliseconds, time duration. All right, so same thing here. I could convert that to N64. And then what happens if I just did like this? It gives me 1 US, or whatever the heck that symbol is. Huh. What is that symbol?
Oh, that's an add-on.
A what?
It's a Greek letter. Nanosecond?
It's a Greek letter for a nanosecond.
I'm not sure. It is a Greek letter.
So that would be, if I had a second and I divided it by 1,000, I'd have a milli. So maybe that's a symbol for milli, 1 millisecond. But if I turn that into N64, it prints 1,000. So just interesting to play with stuff and see why. Great way to learn. So why is this code here? What's that code do?
That's making the message or the item expire. I don't know if it likes it.
Okay, making the item expire. That lights the fuse. And there's no replacing the fuse once it's been lit. Once it's been lit.
So once it's gone.
Because if this wasn't here, right, if this wasn't here, if I just said this, right? Cool? Let's run it. I guess it's still running. Make sure I saved it. And we'll go put in a message. 2-second fuse. That's my message. Submit it. And now as soon as I click this, I'll see the message and that fuse is lit. 1. Should be gone, right? Why is it not disappearing?
Because you never said expiration. There's never an expiration.
It's been more than 2 seconds, right? And it's still here. Still in Memcache.
Yeah.
I did set an expiration.
Oh, okay.
But if within 2 seconds I ask for that page again, what happens? I set a new fuse. So I just set it to 2 seconds again. And I set it to 2 seconds again. And I set it to 2 seconds again. So I could keep that process going forever. Just reset, reset, reset. Huh?
Flags are the fuse.
The flags only let me light the fuse once. So if it's 0, light the fuse. Set this to 1. You're never going to reset that expiration because next time it comes through, that flag is 1. So I can hit refresh, 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 but I've already set my expiration up to Memcache with expiration set to 10 seconds. That's kind of cool. All right, so that's a self-destructing message.
The symbol was mu, and it's micro, millionth.
Oh, it was mu? That's what you call it?
Well, microsecond. But yeah, mu is the letter.
It's mu.
And a nanosecond's a billionth, so that was a...
So it was a milli? Is that right?
No, that's 1,000.
So the mu was what?
A millionth, which isn't there.
Yeah, no, that's a...
A microsecond, that's it there.
Well, if we
No.
took a second divided by 1,000...
A mu s is a single microsecond. A millisecond is 1,000 microseconds.
Oh, okay. There you go. So that's where it is. All right. Cool. So in the next video, we're going to take a look at encryption. It's going to be awesome.